Good morning, everyone. I am Aristódimos Pneumatikakis from Novoville, and thank you very much, Brian, for the introduction. We will see today what we have done and why we have done everything around a system, an AI system for permit processing in smart cities. We will basically showcase how using HumAIne tools made our life easier, both in evolving our system and understanding our system. So without further ado, let's dive into our material. Starting with the project itself, HumAIne is about implementing cutting-edge AI components that try to place the human operator at the center. What they do is they offer a complete control and understanding of the operations performed, and they ensure seamless collaboration between humans and AI. To achieve that, we have four main platform components. The active learning component that puts the human in the loop when facing uncertainty, the neurosymbolic learning that is deep learning together with semantics that come from the experts and assist in complex decision tasks. The swarm learning, that is network AI agents for collective intelligence, and explainable AI that provides predictive explanations with a dynamic user feedback. In HumAIne, we actually actively explore 5 pilot sectors, but our technology, we at least consider it cross-sector. We have smart manufacturing, smart healthcare, smart ticketing, smart energy, and in today's case, smart cities. The project is nearing its end, and it had involved 17 partners from 12 countries. It's a Horizon Europe research and innovation activity. So let's dive now into our challenge. It's in the urban sector, and we are going to consider why permit processing is a representative test case for AI-assisted public administration. So we have a bottleneck here. That's the municipal permit bottleneck. We have resident parking permits that need to be issued, and this is a process that gets repeated multiple times for hundreds of people, many in larger municipalities, thousands of people annually per municipality. It is a process with high procedural standardization, but has a large vulnerability to human errors that stem from fatigue. As a manual baseline, the operators roughly need 20 minutes of time per application to ensure that everything is all right and either accept or reject the application. There is a risk here that runs both ways. We can have false negative, that means legitimate applicants that get rejected, and false positives, meaning erroneous applications being approved. Of course, we don't want any of the two. So we need to keep in mind this baseline of around 20 minutes, and we have this pilot trying to improve this effort needed staff effort needed per application. When we talk about improvement, we don't merely mean accelerate, and you'll see what this means later on. The pattern we have here is one that recurs across many public administration tasks. It starts with some application processing, in our case, parking, but it can be any business permit, any building permit. It needs to be accompanied by some supporting documents, benefit applications, tax filings, and the operator and the municipality side need to perform eligibility determination in order to distribute social benefits, subsidizes. What we have here is a common structure. That means a structured input, a rule-governed decision space, and an accountable human reviewer who retains all final authority of the process. Let's now see the scenario and the user needs around the parking permits. We have a live 3-actor workflow within the municipalities. What are these 3 actors? On the one hand side, we have the citizens that submit applications via a public web form without any login being required. And that's one type of humans involved in the workflow. The other type of humans is the council operators. These people review the flagged or the rejected cases, making the final call on what happens. Traditionally, these were the only people involved in the workflow. The citizen applies, the council operator approves. But we are making the lives of the council operator easier, and the amount of citizens we can serve much larger by putting an AI engine in between. This engine batch evaluates the closed sessions of applications. It compares the form fields to the tax documents and voices its understanding of what is happening. The AI takes some decisions, but those are proposals, not final decisions of the system. The AI can reject a case if there are mismatches, or can flag a case for human review, and also allows all the cases, even those that it passes, to be visible just in case the human operator needs or wants to review more cases. And this is the AI engine in the middle. We follow a 2-tier design principle. The AI performs what we call the first pass filter, and it has 3 decisions. Accepted, when no mismatch is detected. Rejected, when one or more fields are found in a mismatch between the form and the supporting document. And finally, the flagged for verification, which is a subset of those applications that everything looks fine in them, but they are randomly selected for human review. The percentage of these randomly selected applications is a factor of the system that the municipality sets. The larger it is, the more the effort, of course, from the operators. And then we have the second tier, the human final decision. The human, the operator, confirms, overrides, or corrects the AI finding, focusing on the rejected and on the flagged applications. It sees the operator sees the AI reasoning, the original data, and the supporting PDF side by side in a user interface that empower them to do their work. And the operator retains the final attributable authority over the outcome. Why is this a government requirement, government's requirement, and not just a design choice? These are decisions that affect citizens, and as such, they must remain attributable to identifiable human actors. And this decision of ours directly mitigates the highest priority AI-aware risks, the unresolved false positives, the non-explainable decisions, and the erosion of trust in the automation. What each actor actually needs in this workflow? The citizen, they need a simple, non-friction submission process, no login and clear guidance on the documents required. The operators need to be genuinely equipped to exercise judgment, so they are not just nominally in the loop. We have transparent AI reasoning, and we achieve manageable workload and contestability of the AI decisions. The councils, they need to be able to configure the risk tolerance. They need to have full auditability and confidence the system improves, not just accelerates the existing practice. Let's now dive into the HumAIne approach. Based on the HumAIne approach, we try to measure how the collaboration actually works, not just measure what the AI predicts and measure the traditional KPIs of the AI models. Human in the loop is not a guarantee. Whether human oversight is meaningful or merely nominal depends on how the interface we equip the human with is actually built, how the AI communicates the reasoning through this interface, and how operators are supported in exercising genuine judgment. On paper, every human in the loop system looks the same. A human reviews, a human decides. In practice, operators vary widely. Some are prone to challenge the AI outputs. Some interrogate it. Some accept it with minimal scrutiny. The technology is identical across the operators. The accountability the operators exercise when using this technology is not. There are very well-established AI performance metrics that are considered standard today. But what about metrics for human oversight? Well, for AI performance, we have accuracy, precision, recall, we have latency, we have throughput. All of them are well established and widely measured in systems. For human oversight quality, is the human engaging or rubber stamping? Is the resilience calibrating or is it drifting? Such things are rarely measured and rarely required. For HumAIne, collaboration quality deserves the same rigor as prediction quality. So we don't just have KPIs for the first group, the AI performance, but we also try to enumerate the way the human collaborates with the system. And here comes the framework we use in 4 metrics. We have the mean action duration, that's the average human review time per case, the cognitive load proxy, which is the normalized complement of review duration versus a ceiling, the trust proxy, which is the share of operator decisions that validate exactly what the AIs have assessed, and finally, the fraction between the interaction frequency and over the AI inference speed. These metrics can be evaluated purely from standard interaction logs. We don't need any special instrumentations. We don't need any questionnaires delivered to any operators. We just need proper logging of what the system does in all of its steps. So this logging is actually an agreement that we have to reach before we start working that has a particular meaning. We have to have a shared JSON event schema where every interaction log is recorded. We need to explicitly define what we consider correct. That counts the operator validating the AI. For example, the AI rejects, the operator fixes the error and accepts the application because the application had a simple, obvious misalignment. This is counted as agreement. The AI's concern was justified. Another example, the AI rejects, the operator accepts without any correction. This is counted as a disagreement. So the operator overrode the without actually addressing the concern. Why this matters? Because independent evaluators could otherwise interpret the same AI operator decision pair differently. This makes the results reproducible and third-party verifiable. Let's talk a little bit about the tools we will use. We will use the holistic benchmarking suite from the Harokopio University, which provides the HumAIne metrics engine. We'll also be using AI systems from IBM for the PDF extraction and field matching. And also initially an RPA integration layer, which we later abandoned. And from Innovacts, we will be using the HumAIne Swarm Assistant. That's the conversational data exploration. So let's try to put all these together and see some main results and the progress with the system. All the results you will see are applied on the same set of a little bit less than 600 applications. And these applications have been considered by 5 operators. These applications and operators will allow us to evaluate 3 successive AI versions. Let's see these versions. We started with a version from IBM, which had the RPA layer to extract the data. And so we had a simulated UI navigation to retrieve the fields and some simple matching between the supporting document and the data found in the forms. Then we had another version from Novoville where we dropped the RPA layer because it was slow and not really needed, and we used direct API integration. So we eliminated that UI navigation overhead, but at the same time kept the same matching logic from IBM. And then more recently, we had the second model from IBM, which used the direct API integration from the previous model, and also autonomous fuzzy match correction for fields. So obvious errors were corrected by this fuzzy matching system. Let me give you some example of obvious errors. Putting the postcode before or after the city name. This is a mismatch that shouldn't constitute an error. Now this is accounted for. Having a name all in uppercase or with just the first letter in uppercase. Not having the symbol for the tonation of the word in Greek, for example. Such simple things are no longer considered mismatches by this second model. Let's see the traditional KPIs first. We have precision and we wanted very high precision. We achieved almost perfect precision, almost 100%. What does this mean for us, for the municipality? It means that fewer than 2 in 1,000 errors in applications are missed. It's very bad to miss errors in applications because then most probably the operator will not consider these applications, will not scrutinize these applications. And so it's very good that this number is extremely low. Recall, we wanted more than 90%, we got more than 93. This means that more than 9 out of 10 applications marked for consideration actually have errors. That's important because if you continually tell your operators there is something wrong here, there is something wrong here, and there is nothing wrong there, then you will frustrate them. So this doesn't happen by this system. The total processing time of the complete system, both what the user, the operator has to do and the AI has to do. We wanted this to be less than half from the baseline where we had no AI, so just the operator doing the work. And we ended up with 15%. So instead of 330 hours for 1,000 applications approximately, the system plus operators now need 50 hours. And that's a good improvement. Drilling down into the gain for the operator themselves, we wanted the full-time equivalent of their work to be less than 30% from the non-AI baseline, so when they are doing all the work. And it is around 12%, meaning that 88 of the staff time is now freed for higher value citizen-facing work. And finally, we wanted the operator workflow satisfaction as it is measured with questionnaires to be 70% positive. Well, it was 91% positive, meaning again 9 in 10 operators rated the system positively. Yes, that's fine, but these are traditional metrics. Let's now jump into what the holistic benchmarking suite is giving us. Let's focus on the mean action duration. That's the average time the operator spends reviewing a case. And obviously lower is better. These are the dark blue bars, and you see that from model to model, the operator is spending less and less time on average per application. And this is down to a quarter. Then we have the mean AI latency. The mean AI latency dropped from the first to the second model significantly because we got rid of the RPA, and increased slightly in the final model because we actually had a more rigorous matching that took a little bit more time to perform than simple string equality. Nonetheless, we achieved, we are now at the almost 67% drop of the AI latency. So we have here two different mechanisms, but the same favorable direction. The latency reduction that was mostly achieved by transitioning from the RPA to the API integration that cut the AI inference time hugely, and there was less idle waiting inside its review session. And the decision quality that we achieved between version 1 and version 2, where autonomous fuzzy match correction resolved 30 cases in our case, so 5.3% of the total applications, without any operator needing to care about them. So fewer cases actually reached the human for their review. Why this matters? Because this transition from V1 to V2 shows efficiency gains can come from smarter triads, not just faster systems. The system isn't faster, but it's smarter, And that's a distinction that is invisible to the accuracy metrics alone. Moving on to more metrics, the human cognitive load proxy that is derived from the review duration. That's a metric that also improved. The cognitive load improves monotonically from model to model. So operators feel less friction by using successive versions of the model. The final one, the trust proxy, was effectively unchanged, very minimal drop. This is a small gradual decline, and we read it as a healthy recalibration as the automation share rises from 71 to 81%, and it's not anything that erodes the confidence of the operators to the system. One thing that you have to understand is that we didn't come up with these three systems and we then just scored them. We used the benchmarking suite to understand every system on its own and drive the decision on what we should change in the next system. So when we started with this RPA-based integration that had very high and very variable latency, we actually identified that using the benchmarking suite, and we fixed this weakness by having the API integration by Novoville. And that led us to the second system with the direct API integration. But the extraction logic remained the same and the comparison logic remained the same. So although we cut significantly on the latency and the latency variation, we still are flagging trivial mismatches for operator reviews. This is a residual weakness that was also in the first system, but was hidden by the bigger problems there. And it became apparent when we got rid of the bigger problem. And that led to the second system with the fuzzy autonomous correction of today. The application of the tools of HumAIne allowed us to have this progressive evaluation that led to redesign of the system in order to end up with a system that we are all satisfied with. But we are also using a second system from HumAIne, the Swarm Assistant. Here, we have data sets that are increasing both in number as we have more and more models, and in size as we have more and more applications. And we need to be able to explore these data sets and understand things in them and compare things across them. Can we have this exploration in a code-free fashion without any manual data wrangling, no Python scripts, just a direct conversation, question after question against the pilot's own data? Yes, we can have that with the Swarm Assistant. This effectively lowered the barrier for non-technical team members to interrogate the pilot data directly. And we have used it in many real use cases, for example, for data discovery. What kind of data do I have available? Are there directories with PDF files, supporting files? Does every application have has its supporting file? We have document retrieval use cases. Let me see this PDF. We have dataset level queries. Give me all the details from a particular dataset, the full session contents, no manual parsing. Operator decision queries. How many applications have operator decisions and what are they? And also cross-database comparisons, like compare the AI and operator processing times across all the datasets. What is important here is that once we have this rigorous logging system, which is exactly the same as the one we use in the benchmarking suite, ingestion is seamless. The new files can be dropped into the Swarm Assistant, actually into the min.io, that is the document repository for all the tools of HumAIne, and it becomes usable immediately, even mid-conversation. Here is an example of what it actually, the tool actually delivered, the seamless injection that I just mentioned. No code and no manual joins, so real value for the team between formal evaluation rounds. And you can see here the example, the query we issued, um, the explanation of what tools have been used, and the answer with tables, with explaining text and everything. Combine the two tools, well, what they give us, the benchmarking suite is the work engine for rigorous, citable evidence that we use in our manuscripts, in our deliverables, in our KPI tables. On the other hand side, the Swarm Assistant is the fast internal sense check between formal evaluation rounds. Together, we obtain rigorous evidence and fast exploration of the same data, reinforcing the same conclusion that at the end of the day, the final model we came up with, IBM2, outperforms its predecessors. Let's move now to the relevance for stakeholders and adapters. What these tools offer to us can be tampered upon by different applications. So we have now a schema, metrics, contract mechanism on how to log things. All these things are not permit specific. They have made no permit specific assumptions, and they can be used in different domains: clinical triage, content moderation, financial underwriting, regulatory compliance. Each shares the same fundamental structure: a human reviews, an AI recommendation, and the decision event is logged. Only a domain-specific correctness mapping needs to be decided. Once this is decided, and we have a rule of what is considered correct and what is considered wrong, then we can calibrate a cognitive load ceiling, and that's all we need for all these metrics to become available. Let me give you another example of something that we uncovered. We have the same AI given to all 5 of our operators in the municipality, the same interface, but markedly different oversight styles. Let's focus on two particular operators, codenamed operator 4 and operator 5. The duration they had in working with the systems changed. So it took them some time when they worked with the initial version and some to get a result, and some time when they worked with the final system. And you can see that for operator 4, well, they started very, very low. They remained low, okay, even better. And operator 5, they started extremely high and they ended up much, much lower, of course, higher than operator 4. The trust in the final model was exactly the same for the two, but their style, as it was uncovered, was very different. The first operator was very fast and very, very reliant on the AI. The second one was slow, highly scrutinizing, and whenever they were finding obvious mistakes, they wanted to help the citizen by making the corrections instead of actually throwing away the application. And that's why it took them a long time with the initial model that didn't manage to hide away most of the obvious mistakes, but their time dropped very, very much in the final model that actually were able to do that. So here is a provocation for you that has been uncovered by the data. Aggregate metrics alone would have hidden this. The two operators have near identical trust scores through very opposite collaboration styles. One was fast and deferential, the other one was slow and interrogative. Same technology, same interface, but the depth of the oversight was a human variable, not a system one. So the quality of our operators matters no matter what kind of systems we equip them with. Is compliant the same as being trustworthy? What does it mean to be legally compliant? Of course, human in the loop. On paper, it's very easy to achieve. Audit trail needs to exist. And if you have these things, you most probably pass the regulatory checklist. For trustworthiness, though, oversight needs to be measurably active, not nominal. Reliance needs to be calibrated, auditable, and reproducible. Operators in this case are actually empowered. They are not just present there in the loop. Let's now go to a live demonstration of the system. Let me prepare this in a second. Okay, let me move this here. And start sharing. So here you see what the operators and the citizens are faced with. When the citizen visits the page, and now you are not seeing the actual data because the actual data have names, phone numbers, addresses, VAT numbers, and everything of real citizens. So I'm going to show you dummy data here. They land on a page that explains what is being done, that there is a session open for permit application, what this is about, what they will need, how it works, and when they are ready, they start their application, they fill in a very simple form, and they attach their supporting document, they submit their application. There is still information what they need to do. So assume now that I am an operator of the municipality. And what I see here is the current session that is still accepting applications and past sessions. And I can view the current session, view all the applications I have in there. But most importantly, I can stop the session. So it receives no more applications. Now, if I log out, you see that the citizen no longer sees any application, no longer has the possibility to apply. So let's go back here. Fine, sign in. The next thing I can do is run the AI check. So let's applicate it. Let's run it. And if we now view it, then we can see all the sessions, and we can see, for example, that those are the applications that have been corrected. And there are 20 of them that have been corrected by the system. Those are the flagged ones, the rejected ones, etc., etc. Let's return to the sessions, and let's start the operator validation. So now that we can validate, we can go in here and actually find an application that is rejected and actually open it. And we can see the decision, why it is rejected. There was an error in the power supply, and that's the data. Here is the form. The operator goes and finds the power supply and understands that there is a problem, and rejects the application, or accepts the application, corrects things and accepts the application. It's up to them. And here we can see, for example, those that the AI decision was to reject, and is there anything that the operator actually fixed? Here they are. AI decisions rejection, just how many of them? 9 of them, and fixed and accepted by the user, the operator. And you can see the particular fixes were just having to do with the case of the names. And when this process finishes, then the user can actually close the session and notify the people that have their application accepted, so they can pay and then receive their permit. So that's the demo. Now moving from the demo on, building this system used feedback from operators, feedback from reviewers of the project. So what's the feedback about? We had the qualitative feedback on the ease of use, the AI usefulness, and the work impact. All these things were rated positively by all 5 operators. We had a demonstration of this system to 47 operators in our efforts, where we actually teach our operators, the operators in the municipalities we collaborate with using our systems. And after that, they had a satisfaction survey with quite high score. Unfortunately, we don't have any formal validated trust scale instruments applied yet. And we had the recommendations from the reviewers of the project as well that were of interest. And they talked about the real operational data and an expanded data set. And that's why we addressed that with a lot of applications and multi-round evidence, and the recommendation on trust measurement, which was actually achieved via the TR proxy and the rest of the benchmarking suite metrics, and the final planned satisfaction surveys we have. There is one concern on from the operators on job displacement. And what we are trying to show to them and to keep them at ease is that such systems will allow redirection, not and they will not cause replacement. So the FTE time on validation fell to around 12% from the baseline. And this reflects an elimination of repetitive checking. That's not reduced operator authority. We maintain operator authority, but our operators now refrain from fatiguing repetitive tasks. This is reframed as upskilling and redeployment opportunity, with operators involved throughout the iterative refinement we have. Um, Before we move on the Q&A session, I would like to actually challenge you with some questions. So we have 5 questions here, which you can answer online. Also, Brian has shared the poll URL in the chat, but you can see it also up here and type it, or you can scan the QR code. And I would like you to answer the questions, and then we will discuss your answers and move to the next question every time. So please try to. I see that we already have one answer. Now have 4 answers. We can have a maximum of 13 answers. We have 7, 8. Okay. I guess we can start discussing it, and I will keep it open. People can continue voting if they wish. So let's see how you responded. Come on. Not again. Just let me for a second. Okay. So let's see what we have. People somewhat disagree and are neutral towards it. And okay, mainly I see it's neutral-ish towards to disagreement. Okay. So that's a little bit different from what we observed in our pilot. So it will be interesting to know okay, what your own deployments have been and what gives you this mild confidence to disagree. So we could discuss about these things in the after the voting session. Interesting. So let's move to the second question. Okay, as more people are voting, let us start seeing the responses to discuss them. So here we see that it's a little bit balanced, but okay, somewhat disagree is winning. So I'm wondering if you actually mean here that compliance is usually sufficient in practice, or that the distinction itself doesn't hold. Um, maybe maybe it's worth discussing that later on. And moving on. Okay, let's see what we have in terms of responses. Okay, so for the majority of people, it is the standardization that matters. I guess this will be very good news for what the Harkopio University have in mind for standardizing these metrics. Um, Also, regulatory mandate is of importance. Well, that's a little bit outside our comfort zone at Novoville. Indeed, regulation matters, but this is more the topic for EU national policy and not something that we as a pilot can help deliver. Okay, many thanks for this. And now moving on to this question. Okay, so let's see now what we have here in terms of responses. Okay, I see that the vast majority of people have said have selected A and B, which is exactly what this affirms what we at the pilot also how we frame the issue here. So yes, the operators were involved in the refinement, and this helped build ownership. And ownership helped countering the fear of displacement. And for the final question, okay, so the responses, it's mainly B, so for a different process. Okay, that's very interesting. We would love to hear from you as a project across the different use cases that we have, what you have in mind, and maybe try to work with you with using our tools to to do similar tasks. So many thanks for your comments, for your answers.